When you add a resistor in Fusion to your circuit, you'll notice that there are many different resistors to choose from. Have you ever wondered why are there so many resistors, and how do you select the best resistor for your application? Welcome to Why Are There So Many Different Kinds of Resistors? In this video, we'll discuss the technologies, packages, and component ratings of resistors, and what you need to keep in mind when selecting a resistor for your circuit. Well, one reason is size. Making an electronic device as small as possible is a goal of many designers, and surface mount resistors meet this need. Surface mount resistors are available in metric and imperial sizes. The code describes the length and width in inches or millimeters, so an 0805 resistor is 0.08 inches by 0.05 inches. Using the metric code, this same resistor would be called a 2012, as the length is 2 millimeters by 1.2 millimeters. The power a resistor can dissipate is an important consideration. Get it wrong, and your resistor will get too hot and burn out. As you would imagine, the bigger or thicker the resistor, the more power it can handle. But surface mount resistors were not always as common as they are today. At one time, through-hole wire lead resistors were the norm, and they are still commonly used. They are especially suited for building circuits on breadboards. Carbon and metal film resistors are the most common type of through-hole resistors, and generally the larger the resistor, the greater the power handling ability. If you need more than a few watts of power handling capability, then you will likely use a wire-wound or metal foil resistor. Remember, make sure the resistor you select for your circuit can handle the power it will be dissipating. You may recall from video 5, Practical Applications and Considerations Using Resistors, that the voltage divider is a common circuit in electronics. Because it's so often useful to divide up voltage in circuits, adjustable resistors exist to divide up voltage. These devices are called variable resistors or potentiometers, and they come in a variety of sizes and power ratings. But they all consist of a resistive element with terminals attached at each end, and an adjustable wiper that rotates or slides along the surface of the resistance. The symbol for a variable resistor, also called a potentiometer, or pot for short, consists of the resistor symbol and an arrow that represents the wiper. Terminals 1 and 3 correspond to the ends of the resistance, and terminal 2 corresponds to the wiper connection. As stated earlier, potentiometers are used to divide up voltage. Imagine the wiper of this potentiometer is exactly in the middle. This means that the resistance from wiper to ground and wiper to source must be exactly half of the total 1 kilo ohm resistance, which results in half of the voltage at the wiper terminal with respect to ground. The variable resistor is able to provide a change in voltage, or what in earlier days was called potential, and that's why variable resistors are often called potentiometers. Now imagine that the wiper moves up the resistance, such that 80% of the resistance is from wiper to ground, and the remaining 20% from wiper to source. The resistance from wiper to ground would be 80% of the 1K, or 800 ohms, and the remaining 200 ohms would be from wiper to source. In essence, we have a circuit made up of a 200 ohm resistor in series with an 800 ohm resistor, as shown in this Fusion simulation circuit. R1 and R2 reflect the wiper at 80% rotation. As you would expect, 80% of the applied voltage, or 8 volts, will be across the 800 ohm resistance, and the simulation results confirm this. The voltage divider formula is commonly used to calculate the voltage across one resistor when two are in series. Voltage divides up amongst resistors in proportion to a resistor's total resistance. Mathematically, VR1 equals R1 divided by R1 plus R2 times the applied voltage VA, or VR1 equals 200 ohms divided by 200 plus 800 ohms times 10 volts, which equals 0.2 times 10, or 2 volts. Similarly, VR2 equals R2 divided by R1 plus R2 times VA, or 800 divided by 200 plus 800 times 10 volts, which equals 0.8 times 10, or 8 volts. One variable resistor we haven't covered yet is the rheostat. A rheostat provides a variable resistance in a circuit and is a two-terminal device, and therefore only has two terminals. Oftentimes, the wiper is hardwired to the end terminal. Potentiometers can be wired as rheostats, but rheostats cannot be wired as potentiometers. In the next video in our series of basic electronics using Fusion, we explain what capacitors do in a circuit.